Okay, I'm going to continue going through the study guide. I'm up to question number 7. All right, so here we've got two identical rocks. They're dropped from the same height on Earth and on Saturn. Okay, and we want to compare the potential energy of these rocks before they're released. So remember, potential energy equals mass times G times H. So we're told that these rocks are identical, so their masses are the same. We're also told that they're dropped from the same height, so H is the same. So what is different here? Okay, it is the value of the acceleration due to gravity. It's different on Earth and that compared to Saturn, okay, because they're two different planets, they're two different bodies creating two different forces of gravity. So the potential energy of the rock on Saturn is going to be greater than the potential energy of the rock on Earth, because Saturn has a G value of about 28 meters per second versus our 9.8 or our 10 on Earth. Okay. So you don't really have to do a calculation here to compare them. We know that Saturn's is going to be greater because its G value is greater. We said that our other items are the same for both of these rocks. So Saturn's is going to be greater because the G value is greater. Okay, 200 kilogram object was lifted with a crane and it had 18,000 joules of potential energy. How high off the ground was it lifted? So here we've got potential energy equals mass times G times H. And we want to know how high off the ground was it lifted. We want to solve for H. Okay, we're given potential energy. We are given mass. So if I want to solve this equation for H, I'm just going to divide both sides by M times G. That leaves me with H equals potential energy divided by M times G. And to solve that, I have 18,000 joules. That's my potential energy. I'm going to divide that by 200 kilograms times 9.8. Okay. And that's going to give me, let's see here, 18,000 divided by 200 times 9.8 equals about 9.2. I'm going to say about 9.2 meters. So this object was lifted about 9.2 meters off the ground. Okay. Okay, so then we've got a 5 kilogram object dropped from a height of 25 meters, a 50 kilogram object dropped from a height of 2.5 meters. Which one has more potential energy? PE equals M times G times H. G is the same, okay, for both of these objects. So I can really just multiply mass and height to compare them. Okay, so I've got one that has a mass of 5 kilograms and a height of 25 meters. And then I've got one that's got a mass of 50 kilograms and a height of 2.5 meters. I think I know the answer to this one, but I'm just going to go ahead and put it in the calculator so you can see it. 5 times 25 is 125. And 50 times 2.5 is also 125. So they are the same. Okay, because you've got one that's got a mass that's basically 10 times less, I guess, and then your height is 10 times more. So it really ends up, they're the same potential energy. Okay. All right, let's see what else we've got in terms of energy. So here is number 10, a roller coaster. So it rolls over the top of a 30-meter tall hill going 15 meters per second. The mass is 1,400 kilograms. Okay, so what's my potential energy at point A? I'm going to use M times G times H. So I'm going to have 1,400 kilograms times 9.8 times 30 meters. That is, let's see, 1400 times 9.8 times 30 equals 411,600 joules. That's a big number. Okay. What is the kinetic energy of the cart at point A? Let's see. So I think here my cart is at rest at the top of the hill, and then it's going to start going downward. Okay, and then it's going to go. I guess it's going to go 15 meters per second. Well, I don't know. I'm thinking about this. It says it rolls over the top of a hill going 15 meters per second. So let's say at this point it does have a speed as well. It also has kinetic energy as well at this point. So we'll do 1/2 times the mass is 1400 times 15 meters per second. I have to square that. So here I'm using 1/2 times mass times velocity squared to get my kinetic energy. So that's going to be 1/2 times 1400 times 15 squared. Another big number, 157,500. Okay. What is the total energy of the cart at point A? Well, that's going to be my total of my potential and my kinetic. Okay, so that means I got to add up 411,600 plus 157,500 gives me 569,100. Okay, so that's my total energy at point A. That's my potential plus my kinetic. And then what's the velocity of the cart at point B? Okay, so at point B, we have, we're given a height there of 15 meters. So what I'm going to do, this is going to be a couple of steps to get this, but my first step is going to be to get my potential energy at point B. So that's going to be 1400 times 9.8 times 15 meters is my height, 205,800. And then that means my kinetic energy at that point, that's my mechanical minus my potential. Okay, so I'm going to take that 569,100, which is my mechanical total at the top, but that's also my conserved quantity. And I'm going to subtract this 205,800 from that. That's my potential energy. That gives me 363,300 joules. And then if I want velocity, I need to go back to my 1/2 mv squared and solve it for velocity. That's where I have the square root of 2 times my kinetic energy divided by my mass. So let's see what we get when we do that. We're going to have, I don't know if I can, let's see. Let me not do that with so many parentheses. Let me do 363,300. That's my kinetic energy. Times 2 equals a big number. Divided by 1400 is my mass. So that gives me 519. And then I'm going to go back and take the square root of 519. And that gives me 22.8 meters per second. Which makes sense if I'm going 15 meters per second up here. Now my energy is changing from potential to kinetic, so my velocity is going to be increasing, and it's now up to 22.8 meters per second. Okay. Okay, I will stop there and pick up with the next one.